totally get it. I just hope I didn't make them feel bad. That's what bothers me the most. Okay, guys, 7.1. This is where I get really kind of goofy with stuff. I'm going to go on the record as saying I absolutely love what we're going to do in Chapter 7. I absolutely love what we're going to do in Chapter 8. Okay, we're going to be doing a lot of antiderivatives that are going to get more difficult. And for now, you're not going to understand why we're doing it. When we start Chapter 8, you'll see why we're doing all these. Okay, because there'll be a lot of application that comes with Chapter 8. But for now, guys, we've had in Chapter 6 some pretty general antiderivative rules. So in your Chapter 6 notes that you have in front of you right there, if I ask you what's the antiderivative of cosine, what would you tell me?
Negative sign. Or just sign.
Just sign, right? If I said what's the antiderivative of 1 over x, what would you tell me? Natural log of x. If I said what's the antiderivative of 1 over cosine squared, you'd tell me? Tangent. So we're pretty good at those general ones, right?
Yeah.
Okay, so the question that I'm going to start asking you is things like this today. All right. What's the antiderivative of all these messes? And then all of a sudden, we don't really have rules for messes like this anymore, do we? Okay. So my job today is this. Guys, when we start looking at how do you do integration by substitution, the question that we're trying to answer is how do you use derivatives to help with antiderivatives? We want to take, this is what we're really doing today, okay? And maybe write this down. We want to take something that's difficult. We want to take a difficult, if I put this symbol right up here for antiderivative, I want to take it, I can't even spell today, difficult. There we go. Take a difficult antiderivative and turn it into something that's easy. Antiderivative like 6.2. Like in that 6.2 section, with all those rules in there for general antiderivatives, those are pretty easy general antiderivatives, aren't they?
Mm-hmm.
Okay, my job today is to show you a way in which we take something that's very difficult that we're going to look at, a difficult antiderivative, and rewrite it so it's an easier antiderivative, like 6.2, and make it easier to solve. Okay? A lot of things are going to happen here, and I think the first couple will probably be a little confusing. The more we practice this today, and we're going to practice this some more tomorrow for notes, I think the more that we start doing this and you see the process over and over a few times, you're like, okay, I think I know what to do here. So I think this is going to go a lot better than you think. The very beginning, it's very difficult. So the first step today, we need to use derivative of the inside part of a function to establish substitution. Okay? And then we're going to use that substitution to find antiderivatives of, what do we have here? Composite functions. Okay, now I've got some rules here that I think that can maybe help you out here, all right? Guys, when we substitute, we typically let w equal some function, okay? And typically that function is going to be an inside function, but I'm going to talk more about that here in a second. Typically it's like inside of parentheses, or typically it's like underneath a root sign, but sometimes the rules won't apply, okay? I know, all right? Right here. Typically, guys, when we assign w to be something for substitution, which I'll show you in a second, typically w is going to be something that is of the higher power, okay? And then one thing I want you to start getting used to today is this. Instead of using w prime of x for a derivative, I want you to start using what?
dw over dx.
Which stands the derivative of w with respect to which variable?
X.
Okay, so let's just jump right into this first problem, okay? Write small, I think, in here. I think there's plenty of room. Maybe I'm wrong. Okay, here's how this works, okay? Guys, take a look at this first function. All right, normally I would say start with the inside part of this, okay? Now, I have the antiderivative of x times the square root of 1 plus x squared. Is there any rule in 6.2 that looks like, ooh, I can just apply that here and know it right away? Absolutely not. Okay, so here's how things start working for us. What letter did I say is signed to be a substitute? We're going to let w equal something, okay? So every time you start these, you've always got to let w equal something, all right? Now in this case right here, what's that?
Write small.
Yeah, I say write small if you can, okay? In this case right here, I'd probably let w equal the higher power. So if I'm looking at x and I'm looking at the square root of 1 plus x squared, and something like this, if you have something times the square root of something, the part that's typically under the square root is typically, not always, but typically, your w. So what part is underneath the square root sign here, guys?
1 plus x.
1 plus x squared. Okay, here's what we start to do. What we need to do then is to find w prime, or the derivative of w. And here's the step that you need to know. I'm going to say, okay, this means the derivative of w must equal, okay, help me with the derivative over here. And this is where things get confusing, because we've been programmed to do antiderivatives for so long now. We're going back to derivatives and antiderivatives and start mixing them together. What's the derivative of 1 plus x squared?
2x.
2x. But we just took that 2x with respect to what, friends? You agree with that?
Yeah.
Think about this. Isn't the derivative of w really just 1?
Mm-hmm.
1 with respect to w. So this is like 1 dw right here. That's why I can write just dw there. You all right with that? Okay. Then the derivative over here is 2x, but that's with respect to what?
dx.
Okay, now, anytime you do this, the part that's up here, I'm going to put a box around this. This part right here, you always have to figure out what that's going to equal in terms of w. In other words, I'm saying, okay, in this step right here, I want to know what dx would be all alone, okay? This says dx really times what, kids? Okay, dx, get rid of that 2x, I'd have to divide both sides by what?
2.
2x. I want dx all alone. So this is going to become that dw on the left over what?
Over 2x.
Okay, here's the deal. If you can do that part right there, you are ready to find an antiderivative and do it relatively easily. Okay, here's how this works. Now change colors. This is where your substitution starts. Okay, this is going to become the antiderivative of x. That's that first x right up here. Okay, times. All right. This is where things get kind of fun. Square root of 1 plus x squared. But did we let 1 plus x squared equal something here? W. So instead of the square root of 1 plus x squared, we're going to have the square root of, this part right up here was my w, right? Okay, then there was a dx out here, but we just found out that dx is equal to what mess now, kids?
dw over 2x.
Okay, here's what typically happens with stuff, okay? That division of 2x, that 2x is really like on the bottom of everything, because this is all getting multiplied together, isn't it, kids?
Mm-hmm.
Okay. Typically what happens with integration by substitution is you start out with one variable. When we assign w to equal some part of the original function, we should get back to an integral that we're not dealing with x anymore. In other words, we're changing all our x's into what here?
W.
Okay, watch what happens right here. What's this x going to do to this x?
Cancel.
It's gone. It's gone. Okay. Now, divided by 2, that's really what fraction?
1/2.
Okay, I can take that constant 1/2 and move it out front. So this is like 1/2 the integral of square root of w times what?
dw.
Isn't the square root of w just w to the 1/2, my friends?
Yeah.
Now let me ask you this question. Take a look at this integral right here that we started with. And the one that we're at now with substitution, which one looks a lot easier to find the antiderivative for?
On the bottom.
Okay, so here's the deal. Antiderivative now, all right? This becomes, and I'm going to change it to blue now because we're going to start finding our antiderivative, 1/2. Okay, what's the power going to do if I'm looking for an antiderivative? Just like it did over here. It went from 4x squared to 4x to the
Third.
third. This is going to become w to the what?
3/2.
W to the 3/2 all over what? Well, your new power of 3/2, right?
Mm-hmm.
Okay, so what do I have from here? Here's the deal. Guys, I don't like this division of 3/2 right here. So I should probably multiply by the,
Reciprocal.
so multiply by,
2.
so if I get this out of here, it's like 1/2 times 2/3. Squeeze that in there. 1/2 times 2/3 times w to the 3/2. What are the 2's going to do here?
Cancel.
So what fraction am I really left with here?
1/3.
So I'm going to have in the end 1/3 w to the 3/2 plus c. Now that's a great job right there Only problem I have here is this. This antiderivative wanted to be found with respect to which variable? I found the antiderivative with respect to what? But, guys, right here, isn't W equal to something?
1 plus x squared.
So our final solution becomes the following, kids. It becomes 1/3. What am I backtracking with for W?
1 plus x squared.
All to what power? Yep, so this is my W. I replace back with x, 3/2 power. And my friends, that's the antiderivative of that function. 1/3 of 1 plus x squared to the 3/2 power plus c. If you didn't believe me, I could take the derivative of that and see if it takes us back to the original problem, right? I'm going to do that real quickly. You don't have to write any of this down, and I'm not going to show it on the board, but just help me here. Guys, pull the 3/2 out front. What's 3/2 times 1/3? Be 3 up top and 6 on the bottom, wouldn't it?
Yeah.
This becomes 1/2 of what's inside 1 plus x squared. Subtract 1 from my power, that's 1/2, isn't it?
Mm-hmm.
Times the derivative of what's inside by chain rule from a long time ago. What's the derivative inside here? Help me out. What's half of that 2 right there?
1.
So this is like 1x times 1 plus x squared to the what power?
1/2.
Which is really the square root of, right?
Yeah.
Does that go back to the original problem for derivative?
Mm-hmm.
So you know you must be
Right.
right. Okay. Now, be fine and dandy if everybody says, "Yep, got it, Parsons. Move on. Let's go to the next section." Right? I don't think it's that easy. Let's practice these a little bit more. Okay. Guys, the big thing is assign what first? Figure out what dw is in terms of what other variable. In this case it was x. And then once we had that dx out here, get dx alone, start substituting. Everything that was written in x turned into something of the form what? W. We're trying to rewrite everything into a form of w to try and make it an easier antiderivative than what's already given. Okay. Anybody want to guess what you want to set w equal to in the second one?
3x. No.
Second one. Typically pick the higher power. Typically pick the higher power. Okay, I like cosine of x cubed. I'm actually going to go with the part that's just inside, okay, the parentheses. So in this case, I'm going to simply go with the part that's inside parentheses. I'm just going to go with x cubed. Is that okay?
Yeah.
All right, you guys talk me through this. Whoa! Sun came up today. All right, w is equal to x cubed. Here we go. Oh, this stuff, I love this stuff. This is so cool how this works. Okay, anybody want to take the next step for me? Means the derivative of w will equal what, friends?
3x.
3x to the second. But what do I have to put behind it here?
Yeah.
We just took a derivative with respect to x. Now from this, what will dx equal by itself then? What over what? From this one line.
dw over 3x squared.
Very good, dw over 3x squared. Once you've gotten that dx part, or in this case, what are we going to get alone over here in this problem when we get here?
dz.
Yeah. But for now, you get that dx part alone, you're on your way to start making some headway. Okay? So let's roll. Let's substitute. This becomes the antiderivative of, okay, 3x squared, that's not anything, so I'm just going to put 3x squared here, times the cosine of, is there anything that can replace x cubed?
W.
X cubed is w, so the cosine of w. And then what can replace the dx part up here, kids?
dw over 3x squared.
Okay, so we replace the x cubed with w, the dx gets replaced with dw all over 3x squared. But keep in mind, this is like the whole thing over 3x squared. Anybody see anything? 3x squareds are going to go away, aren't they? This is gone. And that's a really good thing now, because instead of having an antiderivative with respect to x, we simply have an antiderivative with respect to what?
W.
So do you guys agree that we're now down to the antiderivative of cosine of w dw? If this is my original antiderivative up here, and I can rewrite it like this, which of those two looks a little easier to work with? First one or second one? Second one. You get down to this, you say, oh, that's a pretty simple antiderivative. I go back to my 6 notes. I say, what's the antiderivative of cosine? You're going to tell me what? Oh, what did I do? What's the antiderivative? I heard you say sine. This becomes the following, guys. It becomes the sine of w plus c. That's the antiderivative, okay? But as everything started out with respect to x, I should probably make this finish with respect to x. So what can I replace the w with, guys?
X cubed.
Okay, so this is actually going to be, in the end, the sine of x to the third plus c as my antiderivative. You guys want to try one on your own, or you want me to walk you through another one? Let's walk through, okay?
Yeah.
Okay, this next one right here. I'm going to, 99.9% of the time I'm going to tell you, if you ever see like a natural log of z or a natural log of anything typically, 99% of the time, that part's your w, okay? And in this case, it kind of makes sense because what part's inside of parentheses?
Natural log.
Natural log of z. And then doesn't this also possess the higher power up top? Yeah. Okay, so you guys talk me through this. I'm going to need some help. So what are you going to let w equal here to start?
Natural log of z.
Okay, so what's that make the derivative of w? Let's see if you remember. We'll see how good you are with this one. This one's a tricky derivative if you can remember it. If you can't, it's u prime over u. Hang on a second. Let me do something.
1 over z.
Say it again.
1 over z.
It's going to be 1 over z. Let me show you this again. Guys, over here, if you go to the calculus part in the web page, there should be a derivative cheat sheet that you might want to call back up again here, okay? Oh, where did it go? All right, there will be a derivative cheat sheet in there by the end of the day. That's the first thing, okay? I don't know where that went today. Maybe I forgot to hit the publish button on it. What's that?
Is the Wi-Fi working?
Well, this is plugged in, so it should be. I don't know where that went today. I bet I forgot to hit the publish button, but there will be one in there. Guys, also, there's some in your book there that you can look at the very back here. But guys, the derivative of natural log of z is 1 over z. This would be respect to what, kids? Right?
Yep.
Okay, so what would I have to get alone right here before I can substitute?
Easy.
Okay. Do you agree getting dz alone would be like multiplied by the reciprocal of 1 over z? So what is the reciprocal of 1 over z?
Z.
So from this, yeah, wouldn't this really be z times dw? dz would equal z times what, your friend? Agreed? Okay, so here we go. Once you've gotten to that part, once you've gotten that d part alone, that part that's there is all alone, your job now is to come in here and say, all right, let's substitute. So this becomes the antiderivative. Okay? Natural log of z changing or staying the same? Changing to what?
W.
Natural log of z is w. So we're going to call this w to the what?
Second.
Over. Is this staying the same or changing?
Stay.
Same. We don't know. Z isn't anything. So just leave it as z. Right here, how the dz part is this, which is now what, kids, for substitution?
Z times dw.
Okay, so this is times z times dw, right? Oh, interesting. When you substitute, most times something should do what?
Cancel.
In this case, what's canceling?
Z.
We're trying to exchange the letter z for variable what? Well, w, and in this case, would the z's cancel mathematically?
Mm-hmm.
These are gone. So after we've canceled, and so I should read it this way. After I've substituted and then canceled, this is now the integral of w squared dw. You tell me, work with that antiderivative or this one? Which one looks a little nicer to work with?
The bottom.
The bottom one does, doesn't it? What is the antiderivative of w squared?
2W.
Not quite, we're going back up on power, so w to the second would become w to the
Third.
third for antiderivative. W to the third over what? Plus some constant c. That would be your antiderivative if we were working with respect to w, but we're not working with respect to w, we're working with respect to, in this case, z, right?
Mm-hmm.
What the heck is this w equal to?
Natural log of Z.
So my final answer here, you're going to have, is it okay instead of having over 3, can I call it 1/3?
Mm-hmm.
And then w was natural log of z, right, kids? Natural log of z, all to the third power, plus some constant c there. Okay, and if I wanted to check again, kids, I could. This would be another chain rule application from a long time ago with derivatives. Help me with the derivative, guys. Bring the 3 out front. What's 3 times 1/3?
3.
3 times 1/3 would be
1.
1.
Sorry.
Natural log of z to bring your power down 1, which is what?
2.
That's the natural log of z to the second part, times the derivative of what's inside here. You told me the derivative of what's inside here was already what over what?
1 over Z.
Times 1 over z. This times 1 over z would lead you back to that, wouldn't it?
Heck yeah.
Okay? Whew. Whew. I mean, look at that. Isn't that beautiful? I think it is. I mean, you can call me crazy if you want, but I think it's wonderful. Kids, take a look at the next one. We've got some trig functions involved, but which power looks to be the highest? The one with sine or one with cosine? So what part is inside with that higher power? Cosine theta plus 5. Anybody want to guess what w should equal? I'm going to have you guys take about 3 minutes and 14 seconds. The sun popped up again. Okay, w equal cosine theta. Again, keep in mind theta is like an x, just a radian measure. Okay, I want you guys to take a couple minutes, see what you come up with for antiderivative. I think you'll be surprised on this one. If you're wondering what the derivative of cosine is, anybody remember what the derivative of cosine is? Negative sine, very good. See what you come up with here. I'm curious to see what you get.
Negative sign or positive sign?
Is it positive 5? Plus 5? Yeah. So what's the derivative of cosine, though, kids? Because the derivative of 5 is just going to go away, isn't it?
Mm-hmm.
Do I need to walk you through a step? See what you guys get here. I'm curious.
tell me if I have the first two steps okay up there. Okay, so do you guys agree that d theta is dw over negative sine theta? Okay, so you talked to me about substituting, so let's rewrite this integral using substitution. So this is gonna become the integral of, okay, let's talk about the sine theta. Is there anything to replace here or leave that?
Leave it.
Sine of theta. Okay, now I got this part inside of parentheses, cosine of theta plus 5. Leave it as cosine theta plus 5 or change it to something.
Change it to W.
W to the what? Fifth. Okay, you all agree there?
Mm-hmm.
And then how about this d theta? Leave it or change it?
Change it.
Change it to what?
dw over negative sine theta.
Okay, how many are with me at least to that point? Good up to there?
Yeah.
Okay, anything you notice right here? After we've substituted, we said it would be really great if some things might start canceling to get everything in terms of W. Anything might fall out here now?
The signs.
Okay, problem being I've got one sign that's positive and one sign is negative, so what's a positive function over the same negative function gonna be? Negative one, right? So you guys agree that this sine theta will cancel this, but it's really what value in the end then?
Negative 1.
So this is like negative one times the antiderivative of w to the fifth dw, isn't it? Okay? Are you with me on that?
Yeah.
Okay, my friends. What's the antiderivative of w to the fifth then? So this is like negative one times w to the sixth over 6, isn't it? Plus some constant c. So we've got our antiderivative in terms of w, so we're gonna go ahead and backtrack. I wanna know what was w equal to originally. Well, what was w equal to originally up here, kids?
Cosine theta plus 5.
Okay, you see this negative 1 and then divided by 6 here. Can I call that negative 1/6 to start? Is that okay?
Mm-hmm.
And then w is gonna get replaced with what, my friends?
Cosine theta plus 5.
All to what power? Because I just took w, but w was raised to what power here?
6.
Sixth. Plus what?
Let's see.
Can I show you something? I don't know if I want to show you this. All right, I think I will show you this. First things first, do these require a little work or no work?
A lot of work.
You're not gonna be able to get them without doing work. That's the first thing I'm gonna tell you, okay? What I will tell you is this, if you wanna check if you're right, remember how we used to go into Desmos and just type in the integral?
Mhm.
And it would give it to you? I don't know if that'll do this. I gotta try. I don't know. We used to put limits in, didn't we? Let's see if this works in decimals, because I haven't tried this yet. I don't think it will. I think it's gonna wanna give me a value. Let's try. I'm not sure if this will work. Functions. Yeah, I think it's gonna want you to put limits in. Okay, how about this? What do we come up with for,
Negative 1/6.
let's see if this works.
Parentheses cosine theta plus 5 to the 6th power plus c.
it's not gonna tell me, is it? I'll explore that a little bit. I'll find a way for you to check. You guys okay with that?
Mhm.
Look at that graph. Isn't that cool? You know what that is? It's just going up and down, and they're all so close to each other. Alright, we'll worry about that later. Let's keep plugging away. I'll find a way for you to check that, alright? Where are we at? Oh, yes, this problem. Guess what, guys? What do you think you want W to equal on this one? Well, let's go back to the very first one.
Cosine, root,
What did we let W equal in the very first one?
what was it? 1 plus x squared.
Because it was under the what?
Root.
Or it's like the inside function, right? So if that logic held up all the time, what would you logically pick here?
X.
Guess what? This is one of the ones where the rules wouldn't apply to that. This is one of the special ones right here. Okay? Alright, turns out here's the deal. Can I give you a hint on this one right here? You're gonna run into some functions at times where part of what's up top might match part of what's on the bottom. And when that happens, typically you take the parts that match each other to be your W. So in this case, instead of being just X, what do you think I'm gonna choose? Not just X, but root of X, okay? So let's talk about this one. This one's a special one, so put a star by this one, okay? Rules don't really apply to this one, and there's some goofy stuff that's gonna happen in this one, okay? I do it all the time. All right, here we go with this, kids. We're gonna let W equal square root of X, right? Which, would you agree that's X to the 1/2 power, kids?
Mhm.
Okay. So let's go to the derivative of W. The derivative of W is going to equal, pull the 1/2 out front. Got 1/2 X to what power? If I subtract 1 here.
Negative.
Okay, now it's going to be very important on this one right here that we start getting some things notationally correct. I do not like negative exponents. So if I wanted that X to have a positive exponent, where would I move it to? Top or bottom?
Bottom.
Bottom, because it's really kind of in the top already. But guys, do you agree that this is now the same as 1 over 2 times X to the 1/2 power on the bottom?
Mhm.
What is X to the 1/2, the square root of X again?
Yep.
Would you guys agree that this really is my derivative right there? 1
Yes.
over 2 root X
Mhm.
with respect to what, my friends?
Yeah.
Okay, now, I need to make a little room here. Actually, I'm gonna wrap this around on this one. This would make dx equal to, okay, if I wanted to get this dx alone, could I multiply by the reciprocal, my friends?
Mhm.
Okay, so this would be, just the reciprocal would be 2 root x, right? So if I multiply by 2 root x, that goes away. It makes dx be alone, doesn't it?
Mhm.
So dx would equal dw times what? Would you agree with that? Okay, now, I don't know how to say, well, let's just go with it. Let's just go with it. Here comes our substitution in red. This becomes the antiderivative of the following. Becomes the cosine of, okay, is it square root of w or just w now?
Just square root? No, just
We let w equal all of what?
square root.
So wherever I see a square root of x, I'm just putting what in here, kids?
W.
Okay, over what, kids?
W.
Okay, why w again? Well, square root of x is what value again? Okay, times, and then what are we replacing dx with? I have a problem. Because I've got an x left in there, I don't see an x to cancel that.
I could turn into a W.
Say that again?
I can turn into a W.
Yeah, isn't that another square root of x sitting in there again, kids? And we just said the square root of x is really what? So what can I really put right here? So if I change this part right here, I'm just gonna drop it out instead of rewriting. If I change that root x to a w here, ooh, are all the x's gone? That's a good thing. What's this w on the bottom gonna do to this w right here?
Cancel.
Okay. This is now 2 times the antiderivative of cosine of w dw. And what's the antiderivative of cosine to this point? Close, it's positive sign, yep. So this becomes 2 times the sine. My antiderivative now would be 2 times the sine of w plus c. And this is the part right here, guys, where we say, all right, I've gotten the antiderivative with respect to w, so let's put it back in terms of the variable that started. Well, w was what? Yep. So this is going to be in the end 2 times the sine of the square root of x plus c. I don't know, you guys tell me, a lot of work. Answer obviously is what? Yes, but once you get through this substitution part and rewrite it, doesn't it become a little bit easier? Remember what we said, we're going to take something that's difficult, do some substituting to make it manageable for us, okay? I don't want to say it's easy, because none of this stuff is easy, but it makes it manageable, all right? Okay, let's get through one more and call it a day. Sound like a fair plan to you guys? Okay, this next one, a little tricky, it's a rational function, all right? There's a numerator and a denominator. Typically when there's a numerator and a denominator with stuff like this, typically, okay, sometimes rules won't apply. Like this one was a rules didn't apply one here, okay? Numerator and denominator possess the higher power. Okay, in something like this, you would take probably your whole denominator and let that be w. Okay, so I'm going to let the denominator of this quadratic function be w. So we're going to call w equal to x squared plus 2x plus 15. Okay? So you guys quickly tell me, what's dw going to equal? 2x plus 2 with respect to what? So from this, if I wanted to get dx alone, what's dx going to equal, my friends?
dw over 2x plus 2.
Very good. dw. Okay. What's next then, kids? We've rewritten some things, and we should probably now do what? Substitute, absolutely. So let's rewrite the problem with substitution. So this becomes the integral of anything for x plus 1 up here, kids. Can you change that, or is it what it is? It is what it is. Okay, how about the bottom? What do you want to call the bottom now? The whole bottom is just what now? W. How about this part right here? What do you want to replace the dx with? Oh boy. Houston, we have a problem. Are the x's going to fall out? No, it would be nice if they did. But look at the x plus 1 and the 2x plus 2 part. Specifically the 2x plus 2 part.
Divide by 2.
Could I factor a 2 out of these here?
Yeah.
So you're telling me there's a chance. Let's see what happens here. Kids, if I take a 2 out of both of these terms, this becomes 2 times what quantity? Oh, well, how does that help? The x plus 1s are gone, right?
Yeah.
My friends, isn't this like a 1 up top times this mess? Isn't this like a 1/2 that I could move to the front? This is like 1/2 times the antiderivative of 1 over w dw now. Okay? Let's see how good you guys are. What's the antiderivative of 1 over w? Natural log of w, right? So our antiderivative is now 1/2. Natural log of w. You've established an antiderivative with respect to w. You better get it back into normal form or original form. Our variable we were working with was what?
X.
What was w equal to in terms of x?
X squared plus 2x.
So my final solution, antiderivative is 1/2 the natural log of x squared plus 2x plus 15 plus c. The hard part's getting started. Once you get stuff down to W form, it goes back to 6.2 stuff, okay? Once you found your antiderivative with respect to W, your job then is to say, okay, what was W equal to in the end? And then backtrack, plug that back in, okay? I think that's a good place to stop. You guys okay with that? Unless you wanna do some more today, be ahead of tomorrow.